Hello everyone. We are now going to learn how to perform subtraction in different bases. But before we go into working on examples in other bases, let's review the process of subtraction in base 10 because we are going to use the similar logic when working in other bases as well. All right, so I'm going to take two numbers here and perform a subtraction in base 10. So I'll choose the number 47, and from 47 I'm going to subtract 35. So the process is that we start from the rightmost column and we look at the number on top. It's a 7 and the number at the bottom is a 5. Now 7 is larger than 5. There's enough in 7 to take away 5. So we perform the subtraction. 7 minus 5 is a 2, correct? Then we go over to the next column to the left. Again, we look at the value on top. The digit on top is a 4, which is larger than the digit at the bottom, which is a 3. So there's enough in 4 to give away 3. So 4 minus 3 is a 1. 12 is the answer. Now, this was a straightforward process of subtraction, all right, because all the digits on top were greater than the digits at the bottom. If we choose another set of numbers, let's keep 47 on top, and from 8 I want to subtract 29. Again, we will start from the rightmost column and we look at the digit on top. We have a 7 here, and at the bottom we have a 9. So there's not enough in 7 to give away 9. Somehow we need this number on top has to be larger than the number that we are taking away, that we are subtracting. So what we do is a process of borrowing from the left columns to the right. All right, so this is the term, or this is the word I'm going to use frequently when explaining or working on examples in other bases. Again, like I said, we're going to use a similar process when working with other bases as well. So what we do is we borrow from the left columns over to the right columns. And what do we borrow? We borrow bundles of ones. All right? We borrow bundles. So remember, when we were discussing addition, we were carrying over bundles of tens. All right, we were carrying over bundles of tens from the right to the left columns. All right. In subtraction, we borrow from the left to the right. And what do we borrow? We borrow a bundle of 10 when working with base 10. All right. So what happens when we borrow one bundle from 4? The 4 becomes a 3, all right? And we give one bundle of 10s to the to the right column, all right? And then the process is we unbundle the 1 and take out the 10 pieces in that bundle, all right? 1 has 10 pieces in it in base 10. So we unbundle it and add that 10 to the 7, all right? We add the 10, and let me write this down below the addition symbol. I'm going to write it here. We add the 10 to the 7, which makes it a 17, which makes the value on top 17. And we subtract the 9 from the 17 because now there's enough in 17 to give away 9. All right? So 17 minus 9, all right? 17 minus 9 is 8, and we write that here. And now we go over to the column on the left. Again, we observe the digit on top is a 3. The one at the bottom is a 2. 3 minus 2 is a 1, 1. There's enough in 3 to give away 2, so this becomes a straightforward addition at this, straightforward subtraction at this point. So 3 minus 2 is a 1. So the final answer is 18. All right, so to summarize, we will be looking at the digits. If the digit on top is smaller than the digit at the bottom, we will borrow bundles, all right, one bundle from the left column, unbundle it, and add the pieces to the digit on top, all right, and then perform the subtraction. And when we borrow 1 from the left, the value on the left has to be reduced by 1, like we did in this case, right? From the 4, we borrowed 1 bundle, so we had to make this 4 a 3, because if it gives away 1 bundle, then it's no longer 4 bundles, it becomes 3 bundles, correct? So we have to remember to subtract 1 from the left or on the left, all right? So we are going to follow a similar process when working with other bases as well, but remember our bundles are going to be bundles of values of the base that we are working in. So if we are working in base 8, then it's going to be bundle of 8. If we are working in base 6, it's going to be bundle of 6. So we'll work through some examples now to explain how that works. Now, before I go into demonstrating a subtraction in base 2, I'd like to correct myself. About 3 minutes in the recording, I probably misspoke saying that we borrow bundles of 1s, and that's incorrect. That was just an error in my speaking. We borrow bundles of 10. So most of you probably figured that it was misspoken, but I just wanted to correct it, all right? We always borrow bundles. We borrow 1 bundle, but in base 10, they are bundles of 10 and not bundles of 1, all right? So we are going to start by performing a subtraction of 2 binary values we see here, base 2 values. So the number on top is 1101 in base 2, and then the number at the bottom that we are subtracting from the number on top is 111 in base 2. All right, so again, we start from the rightmost column. We look at the digit on top and see if it is greater or equal to the 1 at the bottom. So 1 minus 1 is a 0, correct? So I'm going to write a 0 over here. And then we go over to the column to the left. It's 0 and 1. So 0 on top and 1 at the bottom, right? So we need to borrow a bundle of 2s from the left column. So here we have 1. So I'm going to bring this 1 over here, all right? Bring this bundle, one bundle of 2s, so to speak, because we are working in a base 2, and we are going to unbundle. So that bundle has 2 pieces in it, correct? So we do 2 minus 1, all right, which gives us a 1, 2 minus 1. So you are unbundling and then performing the subtraction. Do not do 1 minus 1. You unbundle. In base 2, you will get 2 pieces out of a bundle and then perform the subtraction. So when we borrowed a bundle from here, this became a 0, correct? So we have to go to the left and again see if we can borrow 1 bundle of 2s. So yes, there's a 1 here. So we give this 1 bundle here. This 1 becomes a 0. So again, you have to unbundle first. It's 2 minus 1, not 1 minus 1. 2 minus 1 which is a 1. And then we look to the left, there's 0. So we write a 0. And the end result is 1, 1, 0. Base 2 is our answer. All right, so this is how we will go about working on subtraction with other bases also. So I'm going to work on 2 more examples in 2 different bases, right? Now here's an example of subtracting base 6 numbers. Again, same process to follow, but this time, remember, the bundles that we will be borrowing would be bundles of 6, all right? So again, start from the rightmost column, look at the digit on top. 2 is greater than the digit at the bottom, so this is a normal straightforward subtraction. 2 minus 0 is a 2, and I'm going to write the value 2 here. And then we go over to the column to the left. We see the digit on top is a 1 and the digit at the bottom is a 2. So we need to borrow in this case, right? So we borrow from the left. So borrow 1 bundle of 6, all right? So I'm borrowing 1 bundle, and let me just point the arrow to the bundle, all right? And this bundle now has to be unbundled, and we get 6 pieces from that bundle. So the 6 needs to be added to the 1. So 6 plus 1 is a 7 minus 2. All right. So 7 minus 2 is a 5. So I'm going to write the 5 here. And when I borrowed 1 bundle from this, from the extreme left column, this became a 4, correct? So when I do the subtraction in this column, it will be 4 minus 4. So remember that when you lend, that means when you're borrowing from a value, that a value has to be reduced by 1, all right? So 4 minus 4 is a 0, and our final answer is 052 base 6, or simply 52 base 6, all right? 52 base 6, right? Next, we'll work on an example of subtracting 2 base 12 values. Now, I've listed the numerals for base 12 because they extend beyond the number 9. We have a 10 and 11 in base 12, but we don't use or represent 10 and 11 numerically. Instead, we use the letter A and B to represent 10 and 11 respectively. So let's get started with the subtraction here. We always start with the rightmost column. Look at the digit on top. 3 is a value less than 4. So we need to do some borrowing here. All right. So we have to borrow from the left to this column. So we have a B. B represents 11. So we have to borrow a bundle of 12 from the B. So let's do that here. I'm going to borrow a bundle of 12, right? Well, 1 bundle of 12s is what I mean to say. And what happens when I borrowed 1 from the B, it becomes a 10, all right? So the B becomes an A at this point. But to complete the subtraction of this column, the first column, you take the 12 and you add it to 3. So you have to unbundle and look at the 12 in that bundle. So it's 12 plus 3, which is 15, minus 4. All right, so first you add the 12 to the 3 and make it 15, and then you subtract the 4. So 15 minus 4 is 11. All right, it's 11, but let's write that. It's 11. However, we cannot write 11 because that's not a numeral in base 12. We have to write a B instead. So instead of 11, I'm going to just make it a B. All right. Now we look at the column to the left. We have A and B. Now A has a value 10, B has a value 11. A is less than 11, B. So we have to do some borrowing again here. So we look at the column to its left. We have 3 here, so we have to give a bundle of 12 to this column. So give 1, all right? We give a bundle of 12, right? A bundle of 12, and this 3 will become a 2 at this point. So 12 plus A, all right? We have to add to the number at the top. So let's make it 12. Oops, just a second. 12 plus A, which is 10. 12 plus 10 is 22. 22 minus 11, B is 11. So 22 minus 11 would be another 11, correct? So it would be 11. So we will represent the 11 with a B. So I'm going to write here B. Again, all right? So now we look to the column in the left. 2 is greater than 1. So we just do a 2 minus 1 here. It's a straightforward subtraction. We don't need to borrow anything. So I'm going to write 1. And then finally, the extreme left column is A and 2. So A is greater than 2. That's 10 minus 2 is 8. And that completes the subtraction. Of course, indicate that the result is a base 12 value. So 8, 1, B, B, 2, base 12, not 2. Answer is 8, 1, B, B in base 12. That is the final answer from the subtraction. All right.